All right, we are in section 10.2, the hyperbola. 10.2. Hyperbola, okay? We're on page 925 in your book. Okay? So they say a hyperbola is a set of all points, so a definition. A hyperbola is the set of all points x comma y, okay, in a plane such that the difference in a plane such that the difference, okay, in distances between x, y, distances between x, y, okay, and two fixed points, those two fixed points are called the foci. Foci, okay, is a positive constant. Is a positive constant. That's our definition for a hyperbola. Set of all points x comma y in a plane such that the difference in distances between a point x, y somewhere on the parabola and two fixed points called the foci, okay, is a positive constant, okay? So what do I mean? Well, if you had an XY orientation system, okay, and this picture is on page 925, okay, page 925. And you had a focus right here, equidistant to focus right here, okay? This is actually the graph of the hyperbola. So what I'm saying is there are some points on one of the two pieces of the hyperbola. There's D1, there's D2. So what I'm saying is as you move this point moves from along this hyperbola anywhere, that D1 and D2, this D1 minus D2 is a fixed number. As I move this point from anywhere up or down this half of this parabola, the distance from this focus, this is a focus, and this is a focus. The distance from the point on the hyperbola to that focus minus the distance from the point on the parabola to the other focus, that remains a constant. That's what we mean by this definition. Now, the hyperbola will have a vertex here and a vertex right here. Okay? There's going to be a vertex right there. All right? We talked about the focus. The distance from one vertex to another vertex is called a transverse axis, or this axis rather. From here to here, this is called the transverse axis. Okay? And again, it's the line segment that takes you from one vertex to the other. That's called the transverse axis for a hyperbola. Okay? The distance from there to there is A. So let me give you the different equations. So obviously the transverse axis could be horizontal or vertical. So we're going to look at both situations. We're going to write down the standard equation for a hyperbola where the transverse axis is horizontal, okay, along the x-axis, and we're going to look at a hyperbola where the transverse axis is vertical. So again, this is on page 926. Okay? So standard equation of a hyperbola, centered at the origin. Standard equations of a hyperbola centered at the origin. Okay? And again, two cases. One case is the transverse axis. Okay, the transverse axis is the x-axis. Second case, transverse axis is the y-axis. Okay? So if the transverse axis is the x-axis, the equation is x squared over a squared minus y squared over b squared equals 1. If the transverse axis is the y-axis, the equation will look like x squared over b squared minus y squared over a squared equals 1. Okay? Well, I'm sorry. I got that backwards. Y squared over a squared minus x squared over b squared equals 1. Okay? All right. So let's talk about, and I didn't say it at the time, but this point right here is the center of the hyperbola. That point right there would be the center of the hyperbola. So if I've got this situation, the center is the origin, 0, 0, same thing here. Because we said it was centered at the origin. So the center in both situations would be the origin. Okay? All right. The foci, okay? The foci are going to come from the equation c squared equals a squared plus b squared. So c squared equals a squared plus b squared, okay? And c, that distance c is going to be the distance from the focus to the center, okay? Same right here. The distance from the center to that focus is going to be c. So if you want to imagine this is at 0, 0, then this would be positive c and that would be negative c. So go c units from the center to get to that focus. You'll back up c units from the center to get to that focus. Okay? But the way we calculate the focus is we use a and b. C squared is equal to a squared plus b squared for a hyperbola. So there'll be a focus at negative c, comma 0, and positive c, comma 0, if the transverse axis is the x-axis. And if the transverse axis is the y-axis, the focus will be at 0, c, and 0, negative c. Again, this chart is on page 926. On the vertices, okay? Well, the vertices, again, I said was right here and right here on the hyperbola, okay? And so the vertices would be at a comma 0 and negative a comma 0. Okay? If the transverse axis is the y-axis, the vertices will be at 0a and 0, negative a. Okay? And there's going to be asymptotes. So the asymptotes, if the transverse axis is the x-axis, the asymptotes are y equals b over ax and y equals negative b over ax. Okay? And if the transverse axis is the y-axis, the asymptotes are y equals negative a over b x and y equals positive a over b x. Okay? And finally, they do show us those graphs. Okay? So, again, transverse axis, x-axis versus transverse axis is the y-axis. And again, you can look at these graphs on page 926. So for this one, I'd have negative A, negative. Okay. I'd have negative C and C. Okay. And the way we'll graph these, we're going to graph these hyperbolas, the A and B are going to be used to form kind of a box. So there's B, there's negative B. So we form a box where, again, the width of the box is 2 times A, 0 to A, 0 to negative A. So 2A would be the width of the box. And the height of the box would be 0 to B and 0 to negative B. So 2B would be the height of the box. And then we draw those asymptotes. Well, those asymptotes work out to be exactly whatever this point and this point is, the corners of the box. This will be the asymptote. Y equals B over AX. This corner of the box, this corner of the box, that will turn out to be the asymptote Y equals negative B over AX. And again, this is a vertex for the hyperbola, this is a vertex for the hyperbola, and these asymptotes will help us get the eccentricity of the hyperbola. So start at a vertex, and I'll use this asymptote to figure out how the thing curves up. I'll use this asymptote, start at the vertex, to figure how it curves down. And it won't touch those asymptotes. So there's half of the hyperbola. Over here, use the vertex and this asymptote to write the curvature there. Over here, use the vertex and this asymptote to see how it curves there. So there's going to be the hyperbola. So this one right here represents that hyperbola. So for the transverse axis, the y-axis, I'll do the same sort of thing, x and y, okay? Center is at 0, 0. Okay? And again, the transverse axis here was right here. There's my transverse axis for this hyperbola. So now my transverse axis is going to be the y-axis, right? The y-axis. So again, I'm going to have these foci at 0, C, and positive. So I'm going to have A here, negative A there, C here, and negative C here, okay? And again, A and B are going to be used to form that box. Okay? A and B are going to be used to form the box. And again, as far as these asymptotes, negative A over BX and negative and positive A over BX, you really don't have to worry about those. Form the box and get the corners of the box. That will be one of the asymptotes. Form the box, get the other two corners. That'll be the asymptote. Use the vertex and the asymptote to draw your hyperbola. Vertex and the asymptote. Draw your hyperbola. Vertex, asymptote. Vertex, asymptote. The asymptotes help you define the curvature of the hyperbola. So for this one, the transverse axis is here. Okay, the transverse axis is the axis whose length is 2a, 0 to a, 0 to a. So the length of the transverse axis is always 2a. Okay? So again, the transverse axis is the x-axis, that's this hyperbola. When the transverse axis is the y-axis, that's this hyperbola. Okay? So again, take a look at that on page 726. All right, let's do something. Let's graph some of these hyperbolas whose centers are at the origin. And it'll follow one of these two models we just wrote on the board. So example 1. So to graph an hyperbola. Graph a hyperbola. This is on page 927. Number 1, identify center, they say, and vertices. Okay. Number 2, they say draw the reference rectangle. So draw the box I just told you. Box. And the dimensions of the box are 2a by 2b. Again, this box will have width 0 to A is from here, 0 to negative A is here. So that's 2A. The length of this side is 2A. The height of the box, I go 0 to B, 0 to negative B. So the length of this side is 2B. That's what I mean by dimensions 2A by 2B. The length is 2A, the height is 2B. Okay? So draw that box. Okay? And asymptotes. I just told you about the asymptotes. Asymptotes. Because again, once you get the box, the two corners that are opposite each other, that allows you to draw one asymptote. The two corners that are opposite of each other, that allows you to draw the other asymptote. Okay? Then they say, I said an asymptote, so my number 3 is sketch each branch of the hyperbola. Sketch each branch of the hyperbola. All right. Now, we're going to follow that model, and we're going to do a couple. Okay? We're going to follow this model, and we're going to do a couple. So example 1, given they say x squared over 4 minus y squared over 9 equals 1. And all parabolas are always equal to 1 when they're in standard form. When it's in standard form, you're going to have x squared over y squared, x squared over a squared minus y squared over b squared equals 1. Or y squared over a squared minus x squared over b squared equals 1. But any parabola in standard form is equal to 1. Okay? So they say, A, graph the hyperbola. Graph it. Okay? Well, x squared over a squared, so the a must be 2, because this is a squared. 4 is a squared. X squared over a squared minus y squared over b squared, right? Equals 1. So the a must have been 2. So x squared over a squared minus y squared over b squared equals 1. So the b must be 3, because b squared is 9. Okay? A is 2 and b is 3. Okay? So that means that my vertices, and the center is the easiest part. The center is 0, 0. The vertices, because it says draw center and vertices. The vertices are at 0, a, or a comma 0 rather, and negative a comma 0. So the vertices should be at negative 2 comma 0 and 2 comma 0. Okay? If I want, I can get my foci. C squared is a squared plus b squared. So a squared was 4. B squared was 9, so C squared is equal to 13. C would be equal to the square root of 13. Okay, square root of 13. All right. Well, I've also got asymptotes, y equals, and again, the asymptotes, you can write the formula if you want to and get the actual equation for the asymptote if you want to, but you don't have to. Okay? So the foci would be at square root of 13, 0, negative square root of 13, 0. Okay? Square root of 13, 0, negative square root of 13, 0. So let's draw what we know so far. So there's my x and y axis. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, so the center is 0, 0. I've got vertices at 2, 0, negative 2, 0. The foci is square root of 13. Take your calculator, right? The square root of 13 is a number less than 4, because the square root of 16 would be 4. So the square root of 13, I don't know, approximately I'm gonna say 3.7, somewhere in there. So square root of 13 is between 3 and 4. So there's one foci, there's another foci, all right? Now, we're gonna draw our box. A was 2 and negative 2. The B is a positive 3 and a negative 3. So my box would go from here right? So again, I go 0 to A, 0 to negative A, so the width of the box is 4. 0 to B, B is 3, 0 to negative B, negative 3. So the height of the box is 6, and then I just fill in a box. So again, to draw your asymptotes, one asymptote goes through that corner, those two corners of the box. The other asymptote will go through these two corners of the box. And you could check yourself. You could do y equals b over a, 3 over 2, x, right? That's one asymptote. The other asymptote would be y equals negative 3 over 2x. Well, let's graph y equals 3 over 2x. So if I look at y equals 3 over 2x, if I want to get a couple points on that line, if x is 0, 3 over 2 times 0 makes it 0, y is 0. If x were 2, 3 over 2 times 2 means that y is 3. 0, 0, right here. And 2 comma 3, I go over 2, up 3, that's right here. So again, I see it works. And again, you never have to work to graph those asymptotes. Once you draw that box, one asymptote will pass through these two corners, the other asymptote will pass through those two corners. So I use my vertex, and I know my graph is bounded by the asymptote, so that helps me define the curvature of the hyperbola. There's one half of it, there's the other half of this piece of the hyperbola. Now I gotta draw this piece of the hyperbola. I started my vertex. There's one half of my leaf, there's the other half of my leaf. That would be your hyperbola. Again, the foci would be sitting here and here, okay? The distance from here to here is A. The length from here to here would be A. That's negative A, that's positive A. The distance from here to the center, that's gonna be B. Distance from here to here would be negative B. B was 3. There's my hyperbola, okay? There's my hyperbola. Identify the center, foci. They wanted us to identify the center, vertices, foci, and asymptotes. So we did the center, we did the vertices, we did the foci. These were the asymptotes. Okay? So that's the graph of that hyperbola. All right? So again, identify center and vertices, draw your box. Your box will help you draw your asymptotes, and then those asymptotes and the vertices will help you sketch the two halves of the hyperbola. Okay? So that's how we're going to graph these hyperbolas. All right? Let's do another example. This is example 2. They give us, they say given, they say 16y squared, okay, minus 9x squared, okay, equals 144. All right? Well, the problem with that parabola is it's not in standard form. Again, every parabola in standard form is equal to 1, like this one was, equal to 1. If it's not equal to 1, you've got to make it equal to 1. Make it equal to 1, I divide by 144. But if I divide by 144 there, I've got to divide by 144 everywhere. Okay? If you divide by 144 there, you've got to do it everywhere. Well, 16 over 144. 16 goes into 144 9 times. Minus. 9 goes into 144 16 times. Now it's in standard form. Okay? Now it's in standard form. All right? So again, if you look back at what I initially said, y squared over a squared minus x squared over b squared equals 1. That's the form we have. Look back at the page 829, 26. All right? And the transverse axis is now, transverse axis is on the y axis this time. So the a, since a squared is 9, a is 3. Since b squared is 16, b must be 4. Let's go ahead and calculate our foci. A squared is 9, b squared is 16, that's 25. take the square root of 25, C must be 5, okay? C must be 5, all right? So, look back at that chart. Since A is 3, and we said the center is 0, 0, that's easy. The vertices, instead of A comma 0 like we had there in 0 comma 8, it'll be 0 comma A, so there'll be 0, 3, and 0, negative 3. That'll be my vertices, okay? Because they want me to graph it, identify center, vertices, foci, equations of the asymptotes. The foci, since C is 5, 0, 5, 0, negative 5. Those will be my foci, okay? I think I got enough information to graph the thing. X and Y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have vertices at 0, 3, 0, negative 3. And again, A was 3, right? A is 3, B is 4. So B is 4. 1, 2, 3, 4. Is B? 1, 2, 3, 4. Is negative B. So I draw a box. Okay? At negative 4, so the box would be 4 plus 4, 8 units wide. 3 plus 3, 6 units tall. Look at my opposite. Those help me draw my, what do you call those things? Asymptotes. There'll be another asymptote here. There is a vertex, so again, I started my vertex and used the asymptote to help me define my curvature. Vertex, asymptote. There's one leaf of my hyperbola. Started my vertex, asymptote. Vertex, and use my asymptote. Again, my transverse axis goes from here to here. That's my transverse axis. If I wanted to write the equations of my asymptote, it would be A over B this time. So 3 over 4 x, y equals negative 3 over 4 x. That would be my asymptotes. Okay? And again, I can verify this. Y equals 3 over 4x if I do 2 points on there. When x is 0, y is 0. When x is 4, 3/4 times 4 makes 3. So 0, 0 is the origin. 4 comma 3, I go over 4, up 3, back on. So there's my asymptote. So there's the graph of that one. So pretty easy to draw the graph of these hyperbolas if you follow that model. Identify your center, figure out your vertices. It always helps to know if your transverse axis is horizontal or vertical, all right? You're gonna have to draw that rectangle. That rectangle is invaluable, right? Because that rectangle, the corners of that rectangle are gonna define the asymptotes, right? You can use the corners of each rectangle to help you draw your asymptotes. And once you know your vertex and your asymptotes, you just start at a vertex, you draw the upper half, the lower half for both sides, and you can sketch the hyperbola, okay? So that's how we draw hyperbolas. Well, the next thing is, hyperbolas don't have to be centered at the origin, okay? Hyperbolas don't have to be centered at the origin. They can be centered at any point, h comma k, okay? So, let's look at that situation. Let's look at hyperbolas that are centered somewhere other than the origin. And it's gonna look like what we just did, but there'll be some pretty logical, I think, changes. Okay? So, standard form of a hyperbola centered at some h comma k. Again, now we're assuming that the center of of the hyperbola is no longer at the origin. And again, there's going to be two situations. One situation is the transverse axis horizontal. The second situation is the transverse axis vertical. And again, this chart is on page 929. Okay? It's on page 929. So, if the transverse axis is horizontal, and I'm not going to worry about writing all of this, you can look at that page, over a squared minus y minus k squared over b squared equals 1. If the transverse axis is vertical, it'll be y squared, y minus k squared over a squared minus x minus h squared over b squared equals 1. H comma k would be the center of the hyperbola. Okay? So just like we did before, we're going to list these things. The center would still be not 0, 0, but h comma k. And same thing for him, center h comma k. Okay? The vertices. And again, this is all on the chart on page 929. The vertices would be at h plus a k and h minus a k. If the transverse axis is vertical, the vertices would be at h k plus a, right? hk plus a, I think. Yes. And hk minus a. The foci still hasn't changed. It's still c squared is a squared plus b squared. That's how we get them, right? But the foci will be at h plus c comma k and h minus c comma k. And if the transverse axis is vertical, it'll be at h k plus c or at h k minus c, right? And then finally, those asymptotes. And again, I'm not even going to write down that formula for the asymptotes. I'm not going to write down the equations. I'm just going to show you how to do them. Again, you can look at that on page 929. Let's just do some. All right. So with that in mind, example 3, graph. They give me negative x minus 2 squared over 9 plus y plus 3 squared equals 1. Okay? Well, the first thing I'm going to do is turn that around and write it y plus 3 squared minus x minus 2 squared over 9 equals 1. Okay? And he now looks like that. Okay? He now looks like that. All right? They're trying to trick you writing it in the opposite form. So y minus k, so my center, x minus h, so the x coordinate must be 2, y minus k. So since y is a positive 3, so y minus a negative 3 is y plus 3, right? So that means that k must have been a negative 3. I got y plus 3 squared. And again, the form says y minus k squared. So that just means that the k had been a negative. Because when you subtract a negative, you get a positive. So the center is at 2, negative 3. Okay? The vertices. The vertices. H comma k plus a. So h. And we've already said, okay, this thing is y minus k squared over a squared. So since there's nothing divided by this term, that means that a must have been a 1. So a is 1. B squared is 9, so the b is 3. So again, the vertices are h, k plus a. So k is negative 3, a is 1. and h, k is -3, a is 1. So h, k plus 1, h, k minus 1. -3 plus 1 is -2, and 2, -3 minus 1 is -4. So those are my vertices. 2, -2, and 2, -4. Okay? The vertices would be 2, -3, or 2, -2, I'm sorry, and 2, -4. Okay? Well, let's see what we have so far. And again, I've got y squared minus x squared, so that means transverse axis is vertical. Okay? X, y, 1, 2, okay? So, if I look at this thing, I need to draw my box, right? I need to draw my box. So again, the A, I know my transverse axle is vertical, because it's that second situation right there, not this one, it's that one. So I knew my transverse axis was vertical, okay? I know where the center at. The center is at 2, -3. And I need to modify my graph a little bit. Let me put the graph over here. The center is at 2, -3. X, Y, 1, 2, 3,